significant figures and measurements. In this lesson, we're going to be talking about how to read equipment to the correct number of significant figures. We have a board and 3 differently calibrated meter sticks, which we can use to measure the length of this board. If I was to measure the length of the board with this first meter stick, I know that at the end it's a meter. It looks like it's more than half of a meter, but I'm not sure how much. So maybe 0.6 meters, maybe 0.7 meters. I cannot write 0.55 meters or 0.600 meters because this one would indicate that I know that it's 0.5 while I'm not sure. Or I'm not sure that it's 0.6, maybe it's 0.7. All I know is it's more than half. So I can only have one significant figure. In this next meter stick, I can see more information. And so now I know it's 60-something centimeters, but I'm not sure exactly how many. So I'm going to say that it's 60 centimeters with a decimal. Or maybe I say it's 61 centimeters. Both of these have 2 significant figures. For sure it's 60. What I'm guessing on is this second digit. Again, though, I cannot put 60.0 centimeters because that would imply that I know that it's 60 point something. And finally, on this last meter stick, now I can see that for sure it's less than 61. So maybe it's 60.8 centimeters or 60.9 centimeters. But it's not 61 and it's not 60.900. Okay? So are there differences in the number of significant figures? Yes, this one I could have 1 sig fig, 2 significant figures, and 3 significant figures. And the most accurate is the one that has the most sig figs. Let's look at reading the volume of this burette. We know this one is 25 and this tick mark is 26. So if we were to read it, we know that it's between 25 and 26. We can read up into the 10th place. So 25.20 milliliters. If you can read to the 10th place, then you should have to the 100th place on your reading because it's what you can read accurately plus 1 more. So this is a 30 milliliter test tube. Our liquid line is to here. Go ahead and pause the video and write down what you would record the volume of this liquid to be. On the test tube, there are no gradations. I can say that about halfway is probably around 15. But because there are no tick marks, the most I can have is 1 significant figure. I have 10, 20, 30. Those are my only answer choices that I could possibly have. For sure, it's not 30 or 20 because it's not even halfway, so it must be 10 milliliters. Had you said 7 milliliters or 8 milliliters, that would have also been acceptable as long as there was only 1 significant figure. So our Erlenmeyer flask, so go ahead and read the volume of that one. Restart the video when you have an answer. We know that it's between 450 and 500 milliliters. So you could have said, and that's probably our best answer. You could have put 450 or 460. 470 is probably pushing it. So here's another burette and our liquid line is right there. I'm going to pause the video and try recording the volume for this one. Again, on the burette, we can read to the tenths place, so you should have written a response that was to the hundredths. It's between 36 and 37. It's more than 36.5. It's about 2 down from that. So 36.70 or 36.71. So it's what you can read accurately plus 1. You had to have your answer to the hundredths. If you only had it to the tenths, then your answer would be incorrect. Go ahead and record the mass from this triple beam balance. If you've forgotten how to record mass from a triple beam balance, remember that we have the hundredths place, the tenths place, and the ones place. So our volume, again, or our mass in this case, was 322.15, because I know for sure it's to the tenth, and it's between the 1 and the 2.